Question 13. Show that the points A 1, 3, 5, B 4, 12, 20, and C 3, 9, 15 are collinear. And of course, from the word linear, that means correlate. They have a particular thing that makes them to be able to get placed together. They have one thing in common. That means those 3 points lie on a straight line. So how do you even show that 3 points lie on a straight line? In vectors. The first thing is to actually place them on a straight line, now having an assumption that they lie on a straight line before you can even confirm. And there we go. I have those 3 points. I do not know the ratio into which this point in the middle can divide this line AC, but I can be able to have this as my assumption in terms of what I've actually drawn here. And I will literally indicate those coordinates. So the coordinates are 1, 3, 5, and for B we have 4, 12, and 20, and the last part has 3, 9, and 15. So those are the 3 points that you're supposed to have, and we want to show that those 3 points are lying on a straight line. So I would first take this AB to be my first line. So let me say the first line is AB, forgetting about this last part. So my first line is AB. And of course, 3 points lie on a straight line if they lie all on that line. If they have a particular relationship, they have what you call a common point that can connect them. For example, I have line AB and of course line AC. Have a look at that. I have a line from A to B and a line from A to C. Look at that. So line AB and line AC. So I can say line AB that you've seen here is parallel to line AC. Look at that. So line AB, as you can see this arrow, is parallel to line AC, as you can see these 2 arrows. So AB and AC are parallel to each other. So when they are parallel, then that means we can now come here and say that is there any common factor or what you call a scalar quantity that can actually make this first vector to be equal to this second vector? Because after they are all able to get equated to each other, you can come here and say A is a common point. Why is it a common point? Because I know for AB there is A, for AC there is A. So A becomes a common point for line AB and line AC. They are lying on a straight line if you consider line AB and line AC. And from that point, you can actually realize that A is a common point. So A becomes a common point. That's the first way you can be able to actually show that those 3 points are lying on a straight line if they have a common point. Number 2, I can come here and then get the exact vector of AB, whereby I can be able to say B minus A, and then being equal to AC being C minus A. So we'll proceed. So what is B? We have 4, 12, 20, and A is 1, 3, 5. There we go. Then let's go to C. We have 3, 9, 15, and A is 1, 3, 5. Good. 4 minus 1, that is 3. 12 minus 3, that is 9. 20 minus 5, that is 15. Okay. 3 minus 1, that is 2. Right? Then 9 minus 3, that gives us 6. Then we can now move to 15 minus 5, that is 10. So we don't need to bother so much about this. You can just take one part. Let's even take 3 and 2. So you can come here and say, there is a particular factor that I need to multiply with this part for me to get this. What is it? It can be 1 over 5 or 1.5. So let me have this as 1.5. So 1.5 times 3, that is actually 3. 1.5 times 6, that is 9. 1.5 times 10, that is 15. So then I can be able to come here and say that AB is equal to 1.5 of AC. Or I can decide to say AB is equal to 3 over 2 of AC. Because 1 point 5 is the same as 3 over 2. So that 2AB should be equal to 3AC. So someone can write and say 2AB is equal to 3AC. That becomes our final answer for that. You can still stick to your answer and say 2 over 3AB should be equal to AC. Whichever way you may want to actually put it, that can still give you marks. And for that matter, you've actually gotten a relationship between AB and AC to confirm there's actually a particular vector or scalar that can actually be able to connect those two very important parts of our vector.